The very last thing we are going to do this semester is to talk about solving triangles. And today we're going to look at something to lead us into that, something fairly easy. Today we're going to talk about solving right triangles. What happens when the triangle, we know that it is a right triangle. Later, next week, a couple of days, that's all we have left actually, we are going to talk about solving triangles that might not be right triangles, that might not have a right angle. But the easy case is when we know it's a right angle because we know all about the SOHCAHTOA in a right triangle. Remember, this works in a right triangle. It doesn't work in other triangles. Don't try to use this unless you know you're working with a right triangle. So this is a kind, we've done this kind before. This kind might actually be on your test. The other two kinds that I'm going to talk about here in a minute will not be on your test. But this kind we've done before. We know this. If I have a triangle and I give you a side, in this case I've given you the hypotenuse, and I want to know all the other pieces of this triangle. Solving a triangle generally means we are given three pieces, almost always three pieces, and we have to find everything else. In this case, we have two angles, right angle, another angle, and a side. That's three pieces of information. We knew right away that this had to be 60 degrees because we were solving inside a triangle, has to add up to 180. That's 90 and 30. That one had to be 60. And then we could find, let's say, using the 30, this is the adjacent side and this is the opposite side. I don't like to use O, it looks like a 0. That's adjacent to 30, that's opposite. And we could do things like the cosine of 30 degrees is the adjacent over the hypotenuse, 12, and solve that. A is 12 cosine 30 degrees, and the cosine of 30 degrees is square root of 3 over 2. So this is 12 times the square root of 3 over 2, which is 6 times the square root of 3. And then we could find, so that's 3. That's not a 6. 6 square root of 3. So that's this side. And then we could find this side a couple of ways. The easiest way probably is to write down that the sine of 30 degrees is the opposite over the hypotenuse, opposite 30, p over 12. Multiply both sides by 12. P is 12 sine 30. And the sine of 30 degrees is 1/2. So this is 6. And so I found the three pieces that were missing. What if, however, we're solving a right triangle? We still know it's a right triangle, but we aren't given an angle. So here's a couple of examples. They're essentially the same. There's not much different you can do with them. Here, I'm given an angle, one angle, two sides. I don't know either of those angles. How in the world can I solve this problem? Well, here's what I'll do. I'll call one of the angles, let me just call it theta. That angle is theta. And now I know, well, I know these two sides. I know that the sine of theta, no, not the sine, tangent of theta is 2 opposite over adjacent, 2 over 1, which is 2. So the tangent of theta is 2. So we know, therefore, that what we learned yesterday, theta is the angle whose tangent is 2. Theta is the inverse tangent of 2, right? The inverse tangent is the angle whose tangent is 2. The tangent of theta is 2, so theta is the inverse tangent of 2. I've got my calculator set in degree mode, and I am going to use it to find inverse tangent of 2. So theta is, let's just round to one decimal place, 63.4 degrees. Now, I can find this side. I know it has to be 90 minus 63.4, 26.6. This angle is 26.6. Now I could find this hypotenuse. I'm going to use the Pythagorean theorem. The hypotenuse, 1 squared plus 2 squared, is the hypotenuse squared. That's 1 plus 4 is the hypotenuse squared. 5. So the square root of 5 is the hypotenuse. And so I was given just two sides. I was not given an angle. If I'm not given an angle, I'm going to have to use an inverse trig function. This one is essentially just like the one I just did. I don't know any other angles except the right angle, but I know two sides. And the ones we solved earlier in the semester, we knew an angle and only one side. We could find the other angle based on the one angle we knew. We don't know any angles here. So let me call this one theta, let's say. Call that angle theta. And I know, based on the fact that it's a right triangle, that the sine of theta is the opposite over the hypotenuse, 2/5. So theta is the inverse sine of 2/5. It's the angle whose sine is 2/5. Use my calculator. Inverse sine of 2/5, 2 divided by 5. Inverse sine of 2/5 is 23.6 degrees. So theta, 23.6 degrees. And the 90 minus 23.6 is, this one has to be 66.4. And finally, this adjacent side here, I know that a squared plus 2 squared is 5 squared. Actually, I could have done this first, right? This one doesn't depend on the angles. A squared plus 2 squared is 5 squared. So a squared plus 4 is 25. A squared is 21. A is the square root of 21. This side is square root of 21. Okay, those aren't hard. We're going to elaborate on this after our test. We're going to do this next week. I might put up something on Thursday or Friday. But when it's a right triangle and we have to use inverse trig functions, if we don't use an angle, those are the easy ones.